in class, we're going to work on the section 1.3.3. So head on over to Onshape. Maybe pause this video because I'm just going to move on. So in Onshape, go ahead and create a new document, this time calling it 1.3.3, and I'm going to title it with constraints as kind of an extra part of this name. So that'll create the Part Studio for us to be working in here shortly. So one important thing about sketches in Onshape has to do with constraints. So all design requires constraints. So I'm going to take a moment, I'm going to read what is shown on this page. I know you can pause it and read it as well. But it says a constraint is a limitation or restriction. You've already learned the importance of fully defining the constraints to a problem solution. Unless everyone involved in solving the problem has a clear understanding of the constraint, the development process and the resulting solution could run out of control, wasting resources, time, effort, brainpower, and money, and result in a solution that doesn't work. Similarly, constraints are important when creating 3D solid models in CAD. Limitations to and relationships between elements of a design should be defined early in the process. If they are not, more complex models can become unstable, especially in a parametric model in which each new feature is built on the previously created model elements. It is best practice to fully constrain every geometric detail of a CAD model so that geometry is restricted to only one configuration and cannot be inadvertently reconfigured. Two types of constraints can be applied when building the geometry of a 3D solid CAD model: dimensional constraints and geometric constraints. You've used dimensional constraints in CAD when you apply dimensions to geometric shapes, sometimes known as primitives, when you dimension sketches, and when you define dimensions of features. In this activity, you'll learn about geometric constraints and how a combination of them and dimensional constraints can fully constrain model geometry. So if we look in Onshape and we go to create a new sketch right on the front plane, for example, the geometric constraints are located along the toolbar on the far right, and the majority of them are located in this drop-down. There are things called coincident constraints, and if you hover over it, it tells you exactly what it is and what it does. It constrains two or more entities to share the same location in a sketch. This could be lines, curves, points. Concentric. This constrains circles and arcs to share a common center point. Parallel. This constrains two or more lines to be parallel to one another. Tangent constrains two curves to be tangent. So that would be like two circles that only share one touching point, or a circle that shares one touching point with a line. The horizontal constraint forces one or more lines or sets of points to be perfectly horizontal. I bet you can guess what vertical is. It constrains one or more lines or sets of points to be vertical. Perpendicular constrains two lines to be at right angles to each other. Equal constrains two or more lines to have the same equal length, or arcs to have equal radii. It makes things have the same size. Midpoint constrains a point to the midpoint of a line or arc. Normal constrains a line and a curve to be perpendicular to each other. So it's similar to tangent, except it also forces it to meet at a right angle. Pierce is something that doesn't show up very often, but it does constrain a sketch point or curve with an edge outside of the sketch that intersects with the sketch plane. We will actually utilize pierce anytime we try to add threads to a solid. Symmetric, this is also like a mirroring thing, constrains two geometries to be symmetric relative to a line. Fix constrains the selected sketch geometry so it cannot move, so you can make it stay fixed. And curvature is something that we wouldn't use very often at all, constrains a spline and another curve to match curvature. So I'm not going to worry about too much of that. Let's see what we need to do with these sketch constraints. So we do want to investigate these constraints available in the sketch environment. Okay, we're going to skip a little bit of that. All right, so we're going to create a sketch of a random concave polygon only using the line tool. And then we're going to be sure that all automatically applied constraints except the coincident constraints have been removed. So it doesn't have to look exactly like this picture, but I'll show you what yours might look something like. So starting with the line tool and starting on the origin, all right. So it is closed. It turned gray to let me know that. And if you hover over some points, you can see that there are some specific constraints that would be shown. Okay, so we're seeing that. Oh, if we even hover over that, okay, we can see that, hey, there's a horizontal constraint. There's another one there. I did put a couple of right angles in here, so there are some right angle or perpendicular constraints. But this symbol, the coincident constraint, that means that these two line segments end on this point. And so the end points do overlap one another. That's okay. We want the coincident constraint to stay put. But anything else, they want us to click on and select delete. So if we hover over anything that's not that coincident constraint, coincident is fine. Anything else, there's the vertical constraint, let's get rid of it. Horizontal constraint, get rid of that. All right. So now, if we took away all of those other constraints, we should be able to grab a point and drag these line segments around to make any other sort of shape that we want. If we grab a point and we cannot drag it, that would indicate that we did not eliminate enough constraints. So I turn this into like a crown, basically. Okay. So even that can go up and down. The one point that I won't be able to move is this one, because not only are the two segments ending there, but I also affixed it to the origin. So that's the only point that I'm not able to move. But if I delete one of those, if I delete one of those constraints, looks like I need to delete the one. And that may cause some problems. So now the coincident constraint that held the segments together is no longer present. Okay. So we'll just re-add a line there. And now we're able to drag any point around to make whatever shape we would want. Okay, so we were able to kind of explore that. Now, some of the constraints that show up are automatic constraints that snap to a particular location. For example, the horizontal or the vertical constraints or the perpendicular constraints. Those just show up automatically that get created in the sketch. So those are the ones we have to be careful about unless we really do intend for them to be exactly that, exactly horizontal or exactly perpendicular. So we're going to create a sketch similar to the one that's shown down below. We're going to just use inches as the units. Don't worry about changing it to millimeters. And it says do not apply dimensional constraints. And then it is best practice to draw original sketch elements centered on the origin. So either starting at the origin, or if there is some sort of mirror, like this symmetry, to have it centered on it. As you create the sketch, note any notifications or indications that the program is suggesting geometric configurations. For example, seeing some dashed lines or icons that appear and disappear depending on where you move your cursor. Accept any suggestions that seem appropriate while creating the sketch. So that's what we want to recreate. So I'm just going to X out of this sketch so that it's disappeared. I'm going to start a new sketch on this front plane. So starting from here, we can see the dotted lines, keeping us nice and horizontal. See that keeping it vertical. And so there's a helper line that pops up right there. And then if a helper line doesn't show up, you can also direct your mouse over top of it and then come back up to place it. All right. Is that at all the right shape? No, it is not. I goofed. Okay, so I'm gonna delete that top line and go ahead and add this extra vertical block in. And again, if the helper line doesn't show up, just kind of hover down and make it show up. Okay, so we can certainly, yeah, change these sizes. There are some limits to what we can do, but notice that as I move one side up and down, the other one does as well, because my automatic constraint of making things horizontal went from one side to the other. All right. Review the constraints that were automatically applied as we created the sketch. So we did kind of see that as we went through. When two elements are controlled by a single constraint, represent those dependencies on your sketch. We're going to skip the sketching part. Okay. There's a chance we're going to skip some of this stuff. Okay. This might show us some dimensions maybe later. Wow, there were a lot of steps to this that I'm kind of skipping over. Okay, so we have at least looked a little bit at, what these different constraints do. We know where to find them. Okay. Ooh, there's something that's not constrained. So this point is not constrained to be directly across from that one. So we could apply a constraint and say, hey, make these two things horizontal with each other. So I'm going to go to my drop-down and choose horizontal here. So it actually says pre-select the sketch entities, then click horizontal. So click on each of those dots, then in the drop-down, click horizontal, and one barely shifted. But what we'll see then is that now they go together. They work in tandem. Let's see. Let's try out that symmetric thing because we definitely want to see that happening. So pre-select a line or linear edge and two other geometries of the same type. Click the symmetric constraint tool. So unfortunately we can select that axis line. That's helpful. Okay, so I guess I'm going to click here and there and here. And now I'm going to choose symmetric and see what happens. So the right side shifted in a little bit so that it's now the same distance from the center as that far left edge is. So this works great on parallel items, like those were both vertical lines. You can even do this with points, those 2 points and that vertical axis, and choose symmetric. That brings them in. I'm going to do the same thing with these 2 points. I want them to be symmetric. And lastly, these 2 segments, maybe I'll move one so that it looks distinctly distorted. Okay. There we go. These 2 and that center axis, and hit my symmetry button. There it comes. All right. So that looks really quite good and pretty similar to what the picture they had going on. Okay. So there are lots of constraints now, some vertical constraints, some symmetric constraints. Some coincidence. So I don't actually see the icon for perpendicular, but clearly there's the horizontal and vertical, and we know that those are perpendicular. And so the sketch is still blue, and it will be blue until we fully constrain it. So by that, we're talking about dimensions. So if I go ahead and dimension this to be 5 inches across, okay, some things turn black. So in fact, these 2 segments turn black. They are fully constrained. If we decide what this is going to be, well, that's not fully constrained just yet, but we'll get there. We set this particular width. We never dimension anything diagonally. It's always done horizontally or vertically. Give this a 1.2, for example. Notice that a couple things have turned black already. If it's turning gray, that means it's driven. And so you should click on and delete that because it's already determined that it is a specific size. So we didn't need that one. One thing we do need might be a sideways one here. Nope, we don't need that one. It's gray, that's driven. We should delete it. I feel like we need maybe a couple of heights. So from here to here, again, make sure it's not diagonal, make sure it's vertical. And the last dimension we might need would be this vertical height here. Okay. So once you have everything dimensioned or constrained utilizing the applied constraints, the whole shape has segments that turn black. And that means that the item is fully constrained. So that was your lesson for today. If you need more time to work on something from yesterday, please take your time to do that and get that submitted. You might spend a little longer just kind of exploring these different constraints and seeing what can be done with them. Tomorrow when you come in, you'll be given a new packet and you'll be working on applying some different features in CAD that perhaps you have not yet applied. So thanks for checking this out. Hopefully you learned a few things, and I will see you again later.